Well, there's a good reason why new lithium-ion batteries ship at 40% capacity. This is the charging challenge, to safely charge batteries without overcharging them. As I said in the previous episode, today's mobile innovations would not exist were it not for the battery. All the exciting new technologies rely on lithium-ion battery power. Besides treating mental illness, lithium has the greatest electrochemical potential and the lowest density among metals. These qualities are perfect for mobile batteries. But we need to treat them with care because they could easily go from normal to death device if we're not careful. Let's review the two things that make a great battery: high specific energy creating longer runtimes between charges, and a high cycle count. But most important, safe operation trumps everything. And as with all things, there are trade-offs. In this episode, let's examine these trade-offs by looking at battery chargers. But first, let me start by explaining voltage and current. Voltage is potential energy. Imagine a pitcher of water. When it's stationary, it has the potential to fill a glass. The more water, the higher the potential energy. Current is the amount of electricity going through the circuit, or in terms of our analogy, it's like the amount of water flowing from a pitcher to a glass. Unlike lead-acid batteries, lithium-ion cannot accept an overcharge. Any extra potential energy causes stress.
How?
There is a separator insulating opposing electrodes, keeping the potential energy at bay. If anything metallic bridges the gap, it causes a short circuit. When a lithium-ion battery is overcharged, lithium metal tends to form in between the plates, raising the odds of a thermal runaway if the separator fails. To make matters worse, in notebooks and mobile devices, this separator can be extremely thin. A battery shorts when the insulation separating the anode and cathode breaks down. Now, a few words about chargers. There are two main stages in charging. During this initial stage, the voltage in the battery quickly shoots up at a constant rate as the current spikes and power pours into the battery. During the second stage, the voltage levels off, peaking in the battery as it catches up to the charger's voltage while the current or flow of power is gradually brought down to a trickle. The danger is always overcharging. So there are two charging strategies with lithium-ion: a fast charge or a 100% capacity charge. Each strategy has its pros and cons. In this example, let's focus on two different Apple chargers. For a fast charge, this is the best adapter because it can move a lot of power in a short time. But there are some potential issues. The higher current will get the battery to 70% really fast. In other words, the battery will reach peak voltage quicker, but it doesn't necessarily speed up the overall charging process to 100%. To prevent overcharging during the saturation stage, the current slows down to a trickle, so that the second stage that brings the battery from 70 to 100% may actually take longer. So if you want to get the battery to 70% quickly, there's nothing better than a high-power charger. Just don't expect it to be a quicker way to get to full capacity. Overall, that will probably take the same amount of time. Before you rush out to buy a high-power charger, it would be prudent to make sure the battery can accept an ultra-fast charge, the battery is in good physical condition, and the charger or device has a safety measure built in to reduce battery stress from overcharging. As a side note, some manufacturers include a power cap feature in the device to prevent overcharging. In these specific cases, a higher current may not even make that much of a difference. Now, if you would just like to get to a clean 100% capacity charge and hopefully extend the life of your battery at the same time, the best thing is to use a lower power charger since there is much less risk of overcharging. Think trickling water versus gushing water. I used to think that charging to 100% every time was the best thing for lithium-ion, but it turns out if you're super paranoid about longevity, the sweet spot is 75% capacity. You see, lithium ions behave well when the glass is only 75% full. Naturally, this reduces your daily runtime capacity between charges, but your battery should have a long, prosperous life. And if you want to go deeper down the rabbit hole, partial and random charges are actually good because lower voltage limits are better for the lifespan of the battery. Now, if you're wondering what's the TLDR about charging, first, avoid super cheap third-party chargers. They often claim to charge the battery in less than an hour by providing too much power. At high voltages, the battery can literally burn up if the separators wear away. And always stop using a charger or battery that gets too warm. Also, don't trust a charger's indicator. Even though it may say the battery is ready, it may only be charged 85%, leading some people to blame the short runtime on the phone rather than the charger.
But what if I leave my phone on the charger overnight? Is that bad?
Like I said, good chargers and devices have a standby mode. They'll stop charging at 100% while the device will naturally begin to discharge. But when the battery voltage drops, a good charger kicks in to microcharge the battery back up to 100%, and then rinse and repeat. This cycle goes on indefinitely and actually prevents the wear and tear that comes from overcharging. Let's say you're all ready to start using your new device with the best charger and battery techniques. How should you safely store your old phone or tablet? Well, there's a good reason why new lithium-ion batteries ship at 40% capacity. This minimizes minimizes the stress from high voltages while leaving some room for self-discharge. It also helps to store the battery at the proper temperature. These things should help a lithium-ion battery recover at least 96% of its full charge capacity, even after 1 year of disuse. So again, to maximize battery lifespan, try not to keep the battery at full charge continuously, avoid frequent ultra-fast charging and discharging, use a lower voltage charger, and keep it cool. If your device is constantly running out of juice, it might not even be the battery or the charger. 90% of cell phone batteries returned actually have no problem. In many of these cases, the problem comes from the device itself. So in the next episode, let's look at some common scenarios that might alleviate our battery headaches. And as always, here's a big thank you to all the most recent subscribers. Hitting those like and subscribe buttons let me know what's working and what's not. I will always try to respond to your comments and questions, especially the ones that post the same day as a new video comes out. By the way, it seems that more than a few of you, like me, are Daft Punk fans. That beat you're hearing right now is sampled from their upcoming album, Random Access Memories. There's also a link below to the awesome subscriber and music producer, Tony Ruckus, that let me debut his soundtrack in this video. I hope you keep putting out more music, and thanks for letting me use that track.